NASA was trying to develop plans to go out into deep space after it got these commercial ventures up to the space station. And it was going to try to sell these new plans to the White House. And the gist of the reports is that NASA is going to cobble together its Orion spacecraft, its big new booster, with international components like this habitat from the European Space Agency right here. An Orion spacecraft, a new solar electric propulsion stage. Here's a commercial cargo ship. And this outpost would be sent to the far side of the moon, to one of the Lagrange points, to establish the U.S.'s capability to go into deep space. Get close to the moon, but not land on the moon. And attract international and commercial partnerships to enable it, recognizing that there's not a lot of new money available for this development. But this is the kind of concept that the reporters have been sniffing out at NASA. And so we'll have to see whether NASA succeeds in selling a new agenda to the White House and the Congress and gets authorization to depart from the asteroid goal in the 2020s. So the discussion of these missions into deep space involves working between the Earth and the Moon, and in this gravitational field sketch, we're talking about the Lagrange points, the equipotential gravitational balance points in the Earth-Moon system. L1, 2, 3, 4, 5. Some of you probably know about this more than I do. But L1 and L2 on the near and far sides of the Moon are reasonably stable gravitational points where spacecraft can visit and not spend much fuel to remain there. So these have been talked about as places for this outpost to visit and operate, especially on the far side of the Moon, where you can have direct visual access and radio access to the surface of the far side of the Moon. Lockheed Martin put together this sketch of the Orion on the lunar far side. Astronauts could teleoperate rovers on the surface, have those robots scoop up samples and then rocket them back off the surface. Maybe an Orion or an outpost vessel could return them in the Orion to Earth for analysis. So resume the process of exploring the Moon with robots as our proxies on the surface. And that's the rumor that's going around that NASA's going to try to sell a new deep space ship involving going to the Lagrange points and operate there, in the early 2020s on the way to its asteroid goal. But do something in the near term that's more credible than just jumping off to an asteroid in the mid-2020s. So the new plan is because NASA feels that it's going to lose relevance. It doesn't have something in the near term that it can accomplish and engage the public on. So I assume that there's going to be no budget increase in the coming years, at least in the next 4 years of this administration. No big policy change for the administration. I don't know whether they're going to buy a new NASA plan. I think they would just like space to just be quiet and stay on the side with their other domestic concerns outweighing it. And I don't think that the administration is interested in any big commitments in space leadership. John Holder, the science advisor, a couple of years back addressed a bunch of high school seniors who were award science fair winners from around the country. He had them all in one room here in Washington, and Holder said, the U.S. can't expect to be number one in everything. And so he was telling the students that their country was not going to try to excel in all areas, would have to focus its efforts. I don't think space is one of the areas the administration wants to focus on. So I don't expect a lot of new initiatives from that. My idea is that we're not going to get anywhere substantially different in space other than the space station in the 2020s unless we can find a way to make money among all these celestial bodies. The Earth, the Moon, Mars, the asteroids. We've got to find a way to make space more commercially or economically relevant for us in the coming 10 or 20 years. And unless NASA can embark on a direction like that, a substantial shift in emphasis, we're not going to have much luck in getting to ambitious destinations or missions in space. The private sector's thinking outside the box. Just this week there was a press conference. A company called Golden Spike announced that they're going to start private expeditions to the moon with humans being taken to the moon's surface as paying customers. Whether you're a government, whether you're a corporation, or whether you're a rich individual, if you've got $750 million, you too can walk in the footsteps of Neil and Buzz up there. They announced their startup company and their search for a system to do this starting this past week. They hope to be doing this in the 2020s, making science fiction science fact. The only rub is that even though I know a lot of the people involved in Golden Spike, they don't have a lunar lander. This is just an artist concept. And the development cost for one is approaching $1 billion under NASA's approach. So they're going to have to find a much cheaper way to develop a way to get down to the moon, or else they have a non-starter of an idea. Let me describe what I think we should do in space over the next 10 years. I think NASA, and again, this is a discussion between the President and Congress, NASA can't do it itself, but NASA's going to have to ask for a re-emphasis, a shift in emphasis of its mission. Not just scientific exploration, where we've been for the last 40 years or so since Apollo, but a commercial emphasis. And right in the Space Act of 1958, the NASA Charter, it says, the general welfare of the U.S. requires that the administration seek and encourage, to the max extent possible, the fullest commercial use of space. And that's, I think, the only way that NASA can find itself establishing itself as relevant to the wide 300 million of us out here, the population here at home, be seen to be improving the lives of us materially on Earth by creating a bigger economy for our nation and bringing wealth back to our earthbound society. And it can do that by taking advantage of some of the talents and abilities it already has. So what I would suggest is that NASA should ask for approval to get early access to space resources, both from the moon and the nearby asteroids. And that opens up commercial innovation and space station demonstrations that can show how commercial companies can get wealth or create industry in space. We would have products like water produced from the moon and the asteroids. We'd have rocket fuel from that water, oxygen and hydrogen. We would have metals and dirt for shielding astronauts on deep space missions where the radiation is a concern. Shielding is one of the most expensive things to haul up from the Earth, but we need it to keep human beings healthy on multi-week or multi-month missions in deep space. And opening up these materials in space that are already there to make money will drive the following systems and milestones in my suggestion here. One of the places that we should explore is, of course, the lunar poles, where there's a confirmed finding of lots of water in the form of ice. These are the shadowed craters in purple at the lunar south pole, so cold that they trap water from comet impacts and perhaps from the solar wind, and it's been locked up there for hundreds of millions of years. So we need to prospect that source of water. It's at the bottom of a lunar gravity well, so it's expensive to rocket it off the surface. But roughly speaking, if you want a ton of water in orbit between Earth and the moon, and you get it from the moon, you have to spend a ton to launch it off the moon to get a ton into Earth-Moon space. So there's a penalty to be paid to get off the moon and out of its gravity well. The asteroids don't have that problem in the sense that they are very small by comparison and don't have a gravity field of any significance. So you can ship stuff off at almost free launch cost. But of course, they're farther away. And so the journey back to Earth-Moon space takes longer if you're mining water on an asteroid from the minerals on its surface. Here's the sequence of events, and it's a long list. I don't expect to read them all out loud here, but basically, we're going to start looking for space resources. We're going to do demonstrations very early on at the space station. That'll lead to commercial prospecting for water on the moon. Then we're going to do some asteroid prospecting to look for water and other valuable products. The Orion and Space Launch System will come into the picture in the latter part of the 20-teens. And then we'll be able to start operating in Earth-Moon space between the Earth and the Moon at these Lagrange points. But the mission will not be just science. It'll be commercializing Earth-Moon space. And we'll be conducting activities at L2, perhaps bringing samples back from the moon gathered by robots. And astronauts will be bringing samples back from asteroids, which we're going to bring back to Earth-Moon space. And that's something I want to talk about in the next 5 minutes. A new mission concept that I was on last year, a study team that talked about capturing a small asteroid and bringing it back to Earth-Moon space. Now, why would we want to move an asteroid towards the Earth? The dinosaurs would tell you that's a dangerous move to make. It's a unique and meaningful destination for humans, asteroids are. They're high value because they've got resources on them. We can learn a lot about operating in deep space. They're stepping stones into the solar system. We can have robots do the initial retrieval, and then astronauts can get involved. Lots of good science and engineering experience to come from this activity. It's the only way that by the mid-2020s, the humans will touch an asteroid. And finally, it's safe, and it's exciting, and it's interesting for the human race and our access to wealth in space. We're also sufficiently along with our planning for human space missions that we think astronauts would be able to play a role in recovering this asteroidal material. And you can also see that we're just getting to be able to find small asteroids that we're capable of moving back to Earth-Moon space. The first thing we have to do to accomplish this asteroid retrieval mission is a search for very small, dim asteroids. So we know amateurs play a role in tracking some near-Earth objects. NASA funds a dangerous asteroid search program. We need to find much smaller ones that have the right orbit, the right spectral type, size, shape, spin state, mass, and synodic period or reapproach period with the Earth to go and retrieve one with a robot. And the kind of asteroid we really want to get is a carbonaceous chondrite type asteroid, similar to the meteorites called carbonaceous chondrites. They're water volatile rich asteroids, and they contain about 10% water by weight. Here's a picture of the Murchison meteorite from Australia, 10% water by weight in the clay that makes up the bulk of this asteroid. A Canadian meteorite fall about 5 years ago was even richer in water content. So if we can find an asteroid like this, it's a gold mine, literally a gold mine in terms of the value of the water that can be found there. And the spacecraft to do it, as you saw in that artist sketch, is a rather large solar electric driven spacecraft with a big pink capture mitt or catcher's mitt on the top. The solar arrays are about 30 feet across on each side, powering 5 ion engines, Hall thrusters, to push you at high efficiency out to the asteroid and capture it. And that's the system, the solar electric propulsion system, that enables us to put this spacecraft on top of a single expendable Atlas rocket and send it off to a nearby asteroid and bring it back within 10 years. You can't do it with chemicals, chemical propulsion, because it's just too inefficient. But SEP, solar electric propulsion, can do this. It says Jet Propulsion Lab. And so the sketch of the mission is you launch, you do a gravity spiral out under solar electric propulsion to the moon, get a gravity assist, go out to your asteroid, snag it, come back. It might take 2 to 6 years to come back to a high lunar orbit and get a gravity assist, and then place this into a stable orbit around the moon where astronauts can have access to it. So about a 10-year mission duration from the time you launch, retrieve, and bring back home. Could be a little bit less than that. Spacecraft launches all folded up, deploys its solar panels, thrusts on the way to the asteroid, captures the asteroid in this big basket, and then bundles it up and brings it back to Earth. Simple, right? Here's the notion of what the capture mechanism might look like. It's a graphite composite articulating struts with tendons like that are in your wrist and fingers to snag the asteroid and then lasso it, and then hold it tightly while the ion engines propel you back towards Earth. The mechanism isn't groundbreaking anyway. It's all familiar mechanisms and reels and tethers and so forth, winches that draw the fingers closed. And it would cost only a few $100,000 to do a 1G demo to show that this mechanism could work. And once you retrieved it and brought it back, you would come zinging by the Earth-Moon system, get a gravity assist from the moon, which would loop you into a series of orbits that would put you in a stable orbit high above the moon, where a piloted spacecraft near altitude could come and visit that asteroid. Safety. Why do we want to bring an asteroid back to Earth and have it run into us? Well, there are several measures that would prevent any hazard to us here on the ground. A 70-meter asteroid, the diameter of the one we capture, weighs about 500 tons, but it can't make it down to the atmosphere. It would fragment and burn up. Carbonaceous asteroids are very weak. They're only like dried mud. You can crush them in your fist if you've got the inclination to, and they can't make it through the atmosphere. And the spacecraft will keep it way out there in a stable lunar orbit, not an Earth orbit, away from a collision course with Earth at all times. So we want to make sure that nobody's worried about the possible impacts, literally, of this object. To summarize, this new concept is enabled by solar electric propulsion. It requires people to go out there and then prospect and mine the asteroid. It represents a new partnership or synergy between robotic and human missions. It gets us to the asteroids faster and reduces the risk because they're only going out a few weeks into space to rendezvous with this object. And it provides opportunities for the science folks at NASA, the human exploration folks, international partners, and commercial companies who will provide some of the hardware involved. So it's a pretty exciting thumbnail sketch of what this mission could do for NASA. And then if we had a spacecraft like this that could go out into Earth-Moon space and visit this captured asteroid, we have space resources, commercial companies and partners from overseas sending their robots up there to prospect this 500-ton object, and then starting to demonstrate how you could make it a commercially profitable activity to mine asteroids, either retrieved or out there in the larger near-Earth object population. So what did I say in that chart? Yeah, commercial activity. Oh, planetary defense. If we could move a 500-ton asteroid back here to Earth-Moon system, then you would also have the capability to divert a really dangerous asteroid in the future. So it's a demo of how we could protect the Earth from being hit by a larger asteroid. It would pave the way for astronaut visits out to free-range near-Earth asteroids, NEAs. And I think it would be very exciting to see this mission take off by the end of the 20-teens and be back here in the Earth-Moon system by the mid-2020s. People would watch this in real time as you snagged and despun the asteroid and then brought it back home, knowing that the astronauts were then going to get their mitts on it in the mid-2020s. Here's a sketch from NASA of how you can prospect an asteroid with astronauts on a spacecraft. But the next steps are what I'm really going to focus on here. We have to do a thorough search for these small objects. It's feasible and not expensive. We have to do demonstration on how you can get water out of an asteroid at the space station in weightlessness in some of the lab facilities up there. And at the space station, we can also practice grappling the asteroid and approaches to interacting with it with astronauts and robots. We would do the mission itself, starting in the late 20-teens, and then start sending astronauts out there to rendezvous with it. And that would open up robot and astronaut exploitation and exploration of this local asteroid. NASA would then guarantee to purchase water produced from the asteroids as part of its propellant needs in space. So a 500-ton asteroid would furnish 100 tons of water in Earth-Moon space that you could drink, that you could break into oxygen and hydrogen for rocket fuel, and that you could breathe. The oxygen content could be breathed as well. So a way to save on the $10,000 a pound it takes to take water from the Earth into space. And that would open up commercial activity at the industrial scale starting in the 2020s. And eventually you might have mines on nearby asteroids shipping water and other valuable materials like shielding, like metals, back to Earth-Moon space for industrial activities. The ultimate being putting solar electric satellites in space that could beam microwave energy collected from the sun down to the Earth into our power grid. 50 years from now, this might be a practical way to eliminate the use of fossil fuels along with nuclear energy. So it sounds far-fetched, but a geosynchronous satellite like this might be in operation in 25 years as the first of its kind. When Edison invented the light bulb, nobody envisioned that 50 years later the US would be electrified. So 50 years from now, we might envision that we'd be getting limitless solar power being down to the Earth from space. And that's what space material enables, a reduction in the cost of hauling these materials for construction off the Earth, instead using their equivalents up there in space already. I promised to mention Mars. Curiosity is up there, as you see in the photo. We have NASA talked about goal, a presidential discussion periodically of going to Mars as the next big human step. I really don't think that's going to happen with NASA as the executor of the plan. It's too expensive. It's too risky to send humans in that harsh environment for 3 years to the Martian surface and back. And I don't think any government bureaucrat that I'm familiar with, and I was a government bureaucrat myself, will sign on the dotted line saying, I believe this mission is risk-free and I'm ready to launch. I don't think anybody's going to take responsibility for it. Not a president, not a Congress, not a NASA employee. There's no compelling reason other than scientific knowledge to send humans to Mars, and I don't think that people will judge the cost or the risk of that is worth the substantial risk involved. So the only way we're going to get to Mars, I think, by 2040, 2050, or any time, is for the commercial folks to take a lead and find a way to make it exciting enough to pay for itself, and then maybe governments can follow. So, Mars, robotic exploration for the foreseeable future, returning samples from Mars, astronauts involved in picking up the samples in Earth-Moon space and returning them to the Earth, but I don't think humans will be on Mars anytime in my lifetime. Even though it's a great science fiction goal, I just don't think that we're willing to take the risk of spending the money and seeing it fail. And so robots will be doing the job for us. So, here are my results on my talk and my shift in NASA direction. We need to do things in the near term to show that NASA is engaged seriously in getting into deep space. And that means using the space station to do these experiments on water extraction from meteorite material, like we'll get from the asteroids, and lunar samples as well. And testing of asteroid grappling and anchoring techniques at the space station, where we can do that 220 miles up in just a few years of planning. Less than a couple of years we have experiments like that underway. Bring the asteroids to us with this robotic mission, maybe the first of many. We'll add space resources and a commercial dimension to deep space, and NASA will be demonstrating ways of industrializing space that then the commercial companies can take over. And the money that they make will be taxed and then pay for future space expeditions. The old line from, there's a story about Benjamin Franklin being asked what the benefit of electricity was. It was actually Michael Faraday. So they said, Faraday, what good is all this new electricity you've discovered? And he said, what good is a newborn baby? But he also said, I can guarantee Mr. Minister of the Exchequer, that soon you'll be able to tax it. So that was the interesting factor for the government bureaucrats back in Britain in the 1850s. So enabling commercial activity in space would open up broad activities related to the moon, samples and water from the moon, asteroid water, and then all that experience would pay forward into Mars exploration. And it would put US explorers back into deep space for the first time in 40 years since Apollo 17. So whether any of this is going to be possible, whether anybody listens to NASA's new plans or Tom Jones's new plan, is going to be dependent on what the Congress and the President do with the new budget in 2013, and whether they're interested in reaching some kind of a shift in consensus on NASA's current direction. I predict that they won't get off the dime this year or anytime soon. It might take another election to do that. But if we don't change direction, I think NASA is going to become more and more irrelevant as it falls farther and farther behind schedule with trying to get into deep space under the current plans. So we have to watch for NASA's sales pitch, if it emerges, and what the response from the President and Congress is in the next 6 months. We'll see. Now, I have Neil Armstrong's picture up there because we lost one of my heroes in August. I met him during my work for NASA in the last 10 years. Great individual, one of my heroes growing up. And he's known around the world, as you might suspect. I was in Papua New Guinea for the total solar eclipse last month, and I was lecturing, not lecturing like this, but just talking to some of the school kids on one of the villages in New Guinea. They knew who Neil Armstrong was. And they knew he was an American, and they knew that Americans are a nation of explorers, because we had guys like Neil go all the way out there to the moon, which they could see in the sky. That was part of their knowledge of the US. Now, for 200 years, we've been a nation of explorers with Lewis and Clark and Apollo in the 1960s. We have the question before us about whether we want to continue to be known around the world as a nation of explorers. What's your answer? Thanks very much.